Every app you ever built has one question it needs to answer before doing anything else. Who you are and are you allowed to be here? That's authentication and authorization. If you are a developer, you are going to deal with this for your entire career. But here is the thing. Most tutorials teach you one way to do it, a username and a password form. Maybe Google login if you get lucky. Today, we are going to cover all of it. Password auth, social login, OAuth2, SAML, SSO, machine-to-machine tokens, API keys, and role-based access control. By the end of this video, you'll know exactly which method to reach for and why. Welcome to Building SaaS channel. Let's get started. Before anything else, two words that sound similar but means completely different things. Authentication and authorization. Authentication lets apps know who you are. This is about identity, proving you are who you say you are. Authorization. What are you allowed to do? This is about permissions. Even if I know who you are, can you access this resource? Think of it like a hotel check-in. When you check in, the front desk asks you for ID. That's authentication, proving who you are. Once you are checked in, your keycard decides what you can access. Maybe it opens your room, gym, and pool, but not the manager's office or the server room. That's authorization, what you are allowed to do. Once these two are clear, now let's start with the most simplest thing, simple password authentication. This is where almost everyone starts. A username, usually an email, and a password. The user types their credentials, your server checks them against a database, and if they match, you issue a session or a JWT token to keep them logged in. Sounds simple, and it is, but there are so many other things that you need to take care of. Hashing the passwords, rate limiting login attempts with lockouts and captchas, manage sessions properly by expiring them, invalidating on logout, and storing them in HTTP only cookies. And you need to handle signups too. Verifying emails before activating the accounts, enforcing strong password rules, prevent duplicate accounts on the same email, rate limit sign-up attempts to block bot registrations, and sanitize all inputs to prevent ingestion attacks. Password auth is fine for simple tools or hobby projects, but the moment you are building something real with real users, you should seriously consider adding at least one other option, which brings us to social provider login. You have seen these buttons everywhere. Sign in with Google, sign in with GitHub, sign in with Apple. This is social login. And the reason it's popular is because it solves huge problem. Users hate remembering passwords. Now let's look at what's actually happening under the hood. When a user clicks on sign in with Google, your app redirects them to Google's login page. Google authenticates the user and asks, do you allow this app to see your profile? User says yes. Google sends your app an authorization code. Your server exchanges that code for access token, and you use that token to fetch users' basic info, name, email, profile picture. You create or find their account in your database and log them in. For you as a developer, you are not handling passwords at all. Google handles that, and you trust their answer. This is great for user experience. The downside, you are dependent on that provider. If Google has an outage, users can't log in, and some enterprise clients are not allowed to use social logins at all. They need something more controlled. That's where we go deeper. OAuth2 and OpenID Connect. OAuth2 and OpenID Connect often gets confused with social login because social login uses them, but they are protocols, not a product. Let me explain the difference clearly. OAuth2 is an authorization framework. It answers, can this app act on your behalf? OpenID Connect or OIDC sits on top of OAuth2 and adds authentication. It answers who you are. There are 4 players in OAuth2. Resource owner, the user; client, your app; authorization server, the thing that issues the token, like Auth0, Okta, or Google; resource server, the API your app wants to access. The most important flow to understand is authorization code flow. Your app redirects the user to authorization server with the scope, basically asking what permissions do we need. User logs in and consents. The auth server redirects back to your app with a short-lived authorization code. Your server exchanges that code for an access token and a refresh token. You use the access token to call APIs. When it expires, the refresh token gets a new one without the user logging in again. The key thing OAuth2 gives you is scoped access. An app can ask for just a permission it needs. Read only access to your calendar, not write access, not your contacts, just the calendar. OpenID Connect adds one more thing, an ID token, a JWT that contains the user identity. That's what makes the logins work. If you are building any serious application today, you are almost certainly going to deal with OAuth2, whether you know it or not. Now we are entering enterprise territory. SAML, Security Assertion Markup Language, is older than OAuth2. It was built early 2000s and it uses XML. Yes, XML. It's verbose and painful to debug, but it's everywhere in the large enterprises. Here is how SAML works. You try to access an enterprise app, let's say Salesforce. Salesforce doesn't authenticate you directly. It redirects to your company's identity provider, like Microsoft Active Directory or Okta. The identity provider knows who you are because you are already logged into your company's network. It sends a SAML assertion back to Salesforce, a signed XML document that says, yes, this person is who they say they are, and here are their attributes. Salesforce trusts that assertion and lets you in. Why does this matter? Because enterprises have thousands of employees. They don't want to manage separate passwords for 200 different software tools. They want one central identity system. When someone leaves the company, one deactivation removes them from everything. As a developer, you'll implement SAML when the enterprise customers specifically ask for it. Most auth libraries and providers like Auth0, Okta, or AWS Cognito handle SAML for you, which is a relief because the raw protocol is not fun to work with. Next, let's discuss single sign-on. You use SSO every single day without realizing. Login into Gmail, now you open Google Drive, Google Docs, YouTube. You're logged in everywhere with one login. That's single sign-on. One authentication event grants access to multiple apps. SSO isn't a protocol by itself. It's a pattern that's implemented using SAML, OAuth2, OIDC, or sometimes older systems like Kerberos or LDAP. Now let's see how it works. All your apps trust a central identity provider, the one source of truth for your identity. When you log in into app, the LDAP issues a session. When you then open app B checks with the LDAP, is this person authenticated? And the answer is yes, so you are in. No second login is required. For enterprise softwares, SSO is almost non-negotiable. Big companies will flat out not buy your products if it doesn't support SSO. Because managing 5,000 individual accounts in your app is a nightmare for their IT teams. If you are building a B2B SaaS product, put SSO support on your roadmap early. Everything we have talked about so far involves a human, a person logging in. But a huge part of modern software has no humans involved at all. A cron job that runs every night, a microservice calling another microservice, a CI/CD pipeline deploying your code. There is no one to type a password or click approve. So how do you authenticate? The OAuth2 answer is client credential flow. Your machine has a client ID and a client secret. Think of it like a username and password for a machine. It sends these directly to authorization server. The server responds with an access token. The machine uses the token to call the API. No user involved, no redirects, clean and simple. The tokens issued are usually JWTs, JSON Web Tokens. They are signed so the receiving service can verify they are legitimate without calling the auth server every time. The golden rule for machine-to-machine auth: never hardcode secrets. Use environment variables or secret manager services like AWS Secret Manager or Vault, and rotate credentials regularly. A leaked secret is as bad as a leaked password. Next, let's look at API key-based authentication. If you ever used a third-party API like OpenAI, Stripe, Google Maps, you have used an API key. An API key is a long random string that identifies who is making a request. You include it in request header. The server checks it against the database. If it is valid, the request goes through. API keys are simple and work great for public-facing developer APIs, but they have a real limitation. No expiry by default. If a key leaks, it works forever until you revoke it. No user identity. You know which app is calling, not which user. No fine-grained scopes unless you build it yourself. A best practice is to generate long random keys, scope them to specific permissions if you can, allow developers to regenerate and revoke them, and log every request for auditing. Now let's look at one of the key concepts of authorization, role-based access control. Authentication answers who you are. Now authorization answers what you can do. Role-based access control is the most common model for this. Instead of assigning permissions to individual users, you assign users to roles, and roles have permissions. For example, admin can create, read, update, and delete everything. Editor can only create and update content but not delete. Viewer can only read. A user can get one or more roles. When they're trying to do something, your app checks their role and asks, does this role have permissions to do this action? Role-based access control scales well for most applications. When you need even finer control, like this user can edit their own post but not others, you graduate to attribute-based access control, which is a topic for another video. Alright, let's bring it all together. For simple internal tools, you use password auth. Consumer apps, fast onboarding, social login. Any modern API or web apps, OAuth2 plus OIDC. Enterprise B2B customers, SAML plus SSO. Services talking to services, machine to machine or client credentials. Developer facing public APIs, API keys. Controlling what users can do, role-based access control. The reality is that most production systems use several of these together. You might have a social login and a password auth side by side, role-based access control to control what different users can do, and OAuth for your integrations. You don't need to build most of this from scratch. Tools like Auth0, Clerk, Supabase handles the hard parts. But knowing how each piece works makes you dramatically a better engineer. Because when something breaks, and it will break, you'll know where to look. If this helped, hit the like and subscribe. I've got videos coming up on implementing OAuth2 from scratch and role-based authorization in Python and Node.js. See you in the next one.